Hey everyone, welcome to The Explainer. Today, we're diving into something that is literally the bedrock of modern IT infrastructure. We're decoding the storage alphabet: NVMe, SAS, SATA, and HDD. Our goal today is to completely demystify these enterprise storage technologies. We're going to break down the exact differences between them, pinpoint exactly when you should be using each one, and figure out how you can optimize your enterprise budgets without leaving any performance on the table. Let's get right into it. Here's a quick look at our roadmap for today. We'll start with the storage inflection point, move into decoding the storage alphabet, check out the NVMe performance revolution, look at why SAS is our reliable veteran, discuss why HDDs are absolutely not dead, and finally bring it all together by building the enterprise tier. All right, part one, the storage inflection point. Before we get into the hardware weeds, we really need to acknowledge the massive shift happening in data center architectures right now. For decades, storage was built entirely around sequential workloads, right? But today, we're looking at real-time AI inference, massive Kubernetes clusters, and incredibly high-density virtualization. These workloads demand insanely low latency and massive concurrency. They are fundamentally rewiring what we expect from our storage. Which brings us to a question you really need to ask yourself. Is your legacy storage choking your modern workloads? Mechanical storage systems just weren't built for the highly parallel random access patterns generated by today's cloud-native apps. If your expensive GPU data pipeline is just sitting there waiting on a spinning disk, ouch, that is one very expensive bottleneck. Moving on to part two, decoding the storage alphabet. Let's break down the actual protocols driving the enterprise as we head toward 2026. First up, the big one, NVMe. Now, the name, Non-Volatile Memory Express, kind of gives it away. It's not just a physical drive shape, it's a protocol built from the ground up for high-speed flash memory. By talking directly over the PCI interface, NVMe completely skips that old legacy SCSI command layer. It connects straight to the CPU, basically giving your software stock memory-like, super efficient access. No more legacy protocol overhead holding you back. When you compare the old guard to the new, it really comes down to mechanics. On one hand, you've got hard disk drives, moving parts, spinning magnetic platters, mechanical actuator arms. Physically, they just max out at around 80 to 200 input-output operations per second, or IOPS. On the flip side, NVMe solid-state drives, zero moving parts. Because they use flash memory in a highly parallel architecture, we're talking anywhere from 100,000 to over 1 million IOPS. It's a completely different ballpark. Which brings us perfectly to part three. The NVMe performance revolution. So how exactly does that architecture translate into such massive performance? Look at this number, 65,535. Lock that into your brain for a second. That is the number of queues NVMe supports. And get this, you can have 65,535 commands per queue. To put that into perspective, the legacy SAS architecture relies on a single queue, and it maxes out at just 254 commands. Yeah, 254. That staggering difference right there is the secret sauce behind NVMe's insane concurrency. Think of it like this. NVMe is basically a massive, multi-lane superhighway going straight to your CPU. Huge amounts of data can flow all at once without anybody having to tap their brakes. SAS, on the other hand, it's robust, sure, but it operates more like a single-lane road with a toll booth. That toll booth being the SCSI command layer that every single piece of data has to stop and pass through. And you can literally see this toll booth effect in the real world, looking at some Supermicro benchmark data for 128K sequential read bandwidth. The results are honestly wild. A standard enterprise SATA 3 SSD gives you about 470 megabytes per second. An NVMe SSD absolutely crushes that, pushing nearly 2,800 megabytes per second. That's almost a 6x bandwidth improvement, literally just by switching up the interface and protocol. So to quickly sum up the enterprise advantages of NVMe, you're looking at ultra-low latencies in the 50 to 100 microsecond range. You're getting incredible rack space efficiency, meaning you can pack petabytes of storage into a fraction of the physical footprint. Plus, compared to SAS, NVMe doubles your random mixed IOPS and drops read latencies by 44%. For any new performance-heavy server deployment, NVMe is the default choice, no question. But wait, part four, SAS, the reliable veteran. So with all that NVMe hype, you might think SAS is totally dead, right? Well, not exactly. The SAS protocol, or Serial Attached SCS, is actually a super reliable veteran with a very active roadmap. It debuted back in 2004, hit the massively popular 12 gig standard in 2013, and today the 24G SAS ecosystem is rolling out, with 24G Plus already on the horizon. This technology is definitely not going anywhere. In fact, looking at this roadmap from the SCSI Trade Association, it's clear the industry is still heavily invested in SAS. They're actively developing it to push even higher performance well into 2029. But why? Well, SAS does something incredibly well. High availability through dual-port connectivity. If you're running enterprise all-flash or hybrid arrays where multipath I/O and fault tolerance are strictly mandatory, SAS is still your best friend. For existing shared storage architectures, SAS is that reliable workhorse keeping everything online seamlessly. All right, part 5, why HDDs are not dead. Let's pivot to something people have been saying is dead for over a decade now, the mechanical hard drive. Why are spinning disks still dominating a massive chunk of the data center? Well, Western Digital really hit the nail on the head with this quote. Storage is not one size fits all. Look, I know it's super tempting to just slap NVMe flash on everything, but real-world AI and cloud infrastructure requires a smart, perfectly balanced, tiered ecosystem. Hard drives provide that absolutely essential layer of scalable, reliable capacity. For warm and cold workloads where you don't need instant sub-millisecond access, I'm talking bulk storage, massive data lakes, huge system backups, the spinning disk remains king. It offers a scale that flash just can't touch economically right now. And honestly, economics is the whole ballgame here. 5x to 10x. According to current industry data, that is the cost per terabyte premium you're paying for SSDs over HDDs. When you're buying storage by the petabyte, a 5 to 10 times multiplier dictates your buying decisions. Total cost of ownership always wins out, making HDDs the indispensable foundation for operating at massive scale. Finally, part 6, building the enterprise tier. Let's tie this all together into an actionable strategy for your enterprise architecture. Think of this matrix as your cheat sheet. It's all about picking the right tool for the job. Running latency-sensitive databases, high-density virtualization, or feeding data to AI models, you absolutely have to use NVMe. The performance density there is just non-negotiable. But if you're expanding an existing storage array that needs dual-port fault tolerance, stick with SAS. And for cold storage, massive backups, or giant file servers, deploy HDDs or high-capacity SATA drives for the absolute lowest cost per terabyte. I want to leave you with a bit of a provocative question to take back to your infrastructure teams. Are you paying for performance where you really only need capacity? Or, on the flip side, are you starving your incredibly expensive AI compute nodes with slow legacy storage? Take a good hard look at your data center. Make sure you're matching the right protocol to the right workload. Thanks so much for hanging out with me on this explainer, and I highly encourage you to go audit your infrastructure tiers today.